Hi there, this is another look at some work on quadratic equations, and in particular looking at what's called the discriminant. And the discriminant is a posh name for basically saying we want to know how many times the curve hits or crosses the x-axis. And these are often called roots, and here there's got a picture here. You can see this particular curve hits in two places. It hits here and it hits here. And in GCSE, you often asked to find these places, and you might not realize it, but when you're solving the quadratic equation and writing x is -1 and x is 3, that's really what you're doing. You're finding the two places where the curve hits the x-axis. And this one is what is called a repeated factor, and this one only hits in one place. Its x is 2. But there are equations that are actually impossible to solve using real numbers, and here it doesn't cross anywhere. We say that's got no roots at all. This one, you'll notice, has got one root. This one's got two roots. This one's got no roots. And that's what we're looking at today. So if we quickly have a look at this. Now we'll find all the real roots. Now notice how this the roots very often means solutions, answers. Find all the solutions for these equations, or find all the answers which will make these equations work true. So I've got, well, you'll notice there's very similar ones. X squared equals 10, x squared is -10. So have a go at all of those. I'll pause it, and then, or rather you pause it whilst you're doing it, and then I'll put up the answers. So hopefully you've paused it now. Okay, so these are the solutions. So this is what you should have got. Now when you square root 10, it seems I've got the answers down here. Now, did you remember that? The answer is obviously the square root of 10, which is 3.16. Now, I agree with that, it is, but actually there's two answers. You should remember when you square root, it could be plus or minus. It does say give answers to two decimal places, which is that is the reason for why I've gone from root 10 to 3.16. This one, oh, by the way, on B, I'll do this one first. You can't square root negatives. It's impossible to do using real numbers. So this one is why it says no solutions. Now x cubed, well, that's the cube root of 10. And if you do that on your calculator, what's this? This is C. It looks like it's 2.15. Now bear in mind this. There isn't a plus or minus here. That's a bit of a surprise. You kind of get told this, so you kind of assume plus or minus for squared, so therefore it must be true for cubes. The answer is no. It's not. 2.15 is the only answer. And the other weird thing on this, there is an answer for this, and it's minus 2.15. So you've got different, x squared, you can square root 10, but you get plus or minus. You can't square root -10. Cube root, oh, you can cube root 10, but there's only one answer, and you can also cube root -10. What happens when you get to x to the 4 equals 10? Well, actually, you get a similar thing to what you get up here. If I do the 4th root of 10, which is what you have to do, it seems that the answer is 1.78. But in the same way as x squared gets plus or minus, this is also plus or minus. So this is also plus or minus. And notice it's the even powers. If I was to do x to the 6, that would also give me two answers. Interestingly, you can't find the 4th root of a negative number. It doesn't exist. X to the 5 is very much like the cubic one. Because it's an odd power, I only get one solution. So the 5th root of 10, it would seem, is 1.58. And the 5th root of this, you can do this as well. It's minus 1.58. So I've only put them on just because I think it's a bit of a surprise. You don't often see those kind of questions. But I think it's quite nice to see it. Look, this is the equation we already know. It's quadratic equation formula. And you'll notice x equals minus b plus or minus square root of b squared minus 4ac all over 2a. This is the important bit. And it comes from this idea again that you can't square root negatives. So if this b squared minus 4ac thing is negative, we're in trouble. You can't square root it. So we basically give this b squared minus 4ac its own name. It's called the discriminant. B squared equals b squared minus 4ac. And so you are often asked to find the discriminant and almost we don't care what the answer are, it just says find the discriminant. So in each case, I'm looking at this first one thinking, well, A is 1, B is -6, and C is 9. I very kindly put them all in the right order. You should have x squared, then x, then just a number. And it should always be equal to 0. And it is in this case. So in this case, I'm going to have b squared minus 4ac equals, what's b squared? Well, b squared, well, it doesn't matter. If I square that -6, it will still be 36 minus 4 times the 1 times the 9. Oh, that's good. 4 9s are 36, so that's actually 0. This one, 3x squared. A equals 3. B equals, notice it doesn't say 1x, but it means 1x. So B is 1. And C is -5. So I'm going to write b squared minus 4ac. This is the discriminant. You should learn this formula. Of course, it just comes from this formula up here, but discriminant is often asked on its own right. So what's b this time? It's 1 squared. Well, 1 squared is 1. Minus 4 times 3 times -5. Well, I actually think that's 60. I think that is 61, because a minus times a minus is a plus. And the last one, A is 2, B is -3, and C is 4. So what do I get now? B squared minus 4ac equals, well, b squared this time is -3 squared is 9. Minus 4 times 2 times 4. Well, that's 16. So that's 32. It's 9 minus 32. So minus 23 is the answer. Yeah, so there it is there. 61 I got, and no I got. So the value of these is what we're interested in. And b squared minus 4ac is called the discriminant, but we are interested in, if I have two roots, now I'll tell you right now, this discriminant will be greater than 0. And I want you to write all these things down. We often describe the roots as being real and distinct. Real and distinct. Notice here on the picture it says discriminant is greater than 0. So if I get a number greater than 0, I will have two roots, and they are both different. That's what this distinct means. They're different roots, like there and there, and we describe them as being real and distinct. However, if it is equal to 0, there will only be one root. Notice the picture. It just touches the ones. This sometimes is called just having one root, but sometimes it's a bit weird. Because you're expecting to get two roots, but you've only ended up getting one, we describe it as saying the roots are real and equal. That's a posh way of saying there's only one. But just sometimes you will get a question and it will say a quadratic equation has equal roots. And you go, oh right, that means there's only one of them, because they're equal. And the last one is this idea that b squared minus 4ac is less than 0. So when it's less than 0, this is the kind of picture. The actual curve never ever crosses the x-axis at all. So this is all to do with how many times it crosses the x-axis. This one doesn't. So there's no roots. So when the discriminant is less than 0, there are no roots. And we describe the roots as being not real. A posh word for this might be, you could also call them complex roots. Now those doing further maths will see that more and more, but for A-level maths we don't really care. So let's have a look at this. So I've got three equations, x squared plus 2x minus x plus 2x plus 1. So on this first one, I'm just going to work out b squared minus 4ac. You can see the a is 1, the b is 2, and the c is 1. So when I chuck that in, I get 2 squared is 4, minus 4 times the 1 times the 1. So notice this, a equals 1, b equals 2, c equals 1. And what's this equal? Well, 4 times 1, that's 4, so 4 taken 4 is 0. So on this one, I'm going to describe part number 1 as having equal roots. That's what I would say. Maybe real and equal roots, but definitely equal roots. There's only one root, is the other way of saying it. So notice whenever you get 0, there's only one root, or we describe it as having equal roots. Let's do the second one. This time the a, let's write these out here. A is 1, b is minus 2, and c is minus 1. So if I do b squared minus 4ac, what do I get? I get 4 again. 2 minus 2 squared is still 4, minus 4 times 1 times minus 1. Oh, that minus 1 matters, of course, because minus times 1 minus is a plus, so this is really 8 when I do it. And when you get, as I showed you before, when it's greater, you can square root it, and therefore we will get 2 real and distinct, that means different, remember, roots. And this last one, a equals 2, b equals minus 3, c equals 5. So b squared minus 4ac. Square that, I get 9 minus 4 times 2 times 5. Well, that's 10, 40, I reckon it's minus 31, and critically it's less than 0. This one was greater than 0, this is less, so this is no real roots. And that's hopefully what that says. So, next one, which graph is which? Well, you can see this quickly. It says use the discriminant, so I'm just going to do this, discriminant. An easy one, this is often used for the discriminant as well, this capital, this is b squared minus 4ac, it's just a lazy person's way of writing it, so from now on I might write that. But b squared is 36 minus 4 times 1 times 9. Check your a, b's and c's, I reckon it's 0. So I reckon this one here is a, because it only touches once, because it's 0. When it's 0, there's only one root. This one, b squared minus 4ac, b squared this time is 1 squared minus 4 times 3 times negative 5. So 4 3's are 12, 60. Is this the same questions as last time? It may well be, though. 61, that now starts ringing bells. 61 means it crosses in 2 places, so this must be it. You can see this one crosses in 2 places. So this one is B, and presumably this one's C. So on this last one then, I'm just going to quickly check. I'm going to do the discriminant again. I've got b squared, which is 9, minus 4 times the 2 times by the 4. 4, that's, what's that, 32. 9 minus 32 is minus 23. Which, again, tells me there's no roots, it's less than 0, no roots, so therefore, notice it doesn't cross. So I'm happy with that. Discriminant and inequalities. Now, this is going to get perhaps a little bit tougher, so I'm tempted to just show you a little bit of this, and maybe we'll finish it in the lesson. So find the range of values of x, given that x squared minus 4x plus k equals it. Now, whenever they throw in a k, that basically means we've got a backward question. Because it says we've got no real roots, you see. So I already know that b squared minus 4ac, because there's no real roots, it has to be less than 0. That was our rule. When you get no real roots, it's less than 0. So look at this. What was my a? My a was 1, my b is minus 4, and my c is k, which is a bit odd. But anyway, I'll put them in. B squared, if I square minus 4, I get 16. Minus 4 times the 1 times the k. And I know it's less than 0. That's the whole point of that statement. 16 minus 4k is less than 0. So 4k, well, what I need to do perhaps is move the 4k over. So I'm going to write 16 is less than 4k. I don't like it that way round though. But when you switch inequalities around, you have to change the sign. So it means 4k is greater than 16, or k is greater than 4. That's what they want you to write here. K is greater than 4. And this one's got, I think this is the last question. So it's probably, oh, and then some homework help as well. So it's probably a good point this for me to pause the video. We'll finish this in lesson time. And hopefully then we'll be able to make a good start. So thank you very much.